In this series of videos, I'm attempting to repair and restore this Osborne OCC1 Vintage computer. In the series so far, I've gone through various repairs, and normally I kind of skip through repairs fairly quickly. I'll say I've found a fault and fixed it, but I don't normally go into too much detail about it because it would make the series of videos very long and probably quite boring. But the particular fault I'm working on at the moment I thought was fairly interesting. In fact, I said at the beginning of it that this was a particularly interesting fault and it should make quite an interesting part of the repair. And there was a particular reason I said that, and I asked for comments and feedback, and thanks to all the people that commented. It does make it much easier knowing what your thought processes are, because it makes it easier to target the videos and give information that I hope is going to be helpful. And that's really what I'm aiming at. I'm trying to make it easier for people to fault find on equipment like this. And someone did say in one of the comments, they quoted Occam's razor, that the simplest answer is probably the correct one. That's not really something you can apply to these repairs, and especially repairs like this particular one, and that's specifically why I said it should be a fairly interesting repair. His theory was that it was just a faulty or mouldy disc, and I did say no, I have tried quite a few, and in fact by the time you ever see me on a video saying a piece of equipment is faulty, it's normally after quite extensive testing. I would never just put a disc into a machine and it failed to format and then decide to make a video saying that it's faulty. That's not something I would ever do. So by the time you see me saying something's got a fault, you can rest assured that I've done quite a lot of testing and tried various things. I don't just go through knee-jerk reactions of saying something's faulty. So I thought it'd be interesting at this point to cover off certain comments. And I'm not trying to get at anyone here or criticise anyone. A lot of the comments were kind of valid, but really what you need to do is look at everything together rather than just make assumptions about an individual part of the fault. Now, it is quite difficult on a machine like this because this wasn't a machine that was working and subsequently failed with a presumably single fault. This is a machine that wasn't really working at all, so more than likely it had numerous faults. So I'm going to power this up and we'll just quickly look at the issue that we were having. Now, if you recall from the previous videos, it would boot from floppy disk, but it won't format or copy to a disk, and it doesn't matter whether I'm using the actual disks or Gotex or whatever else, the fault is very similar. So I power it up. We'll wait for the start screen to come up. So there it is. Apologies for flicker as usual. And I've got a boot disk in this drive, so we'll boot to that disk. Got the keyboard down here, by the way, you can possibly just see the top of it. Okay, so we'll boot it to CPM. We'll put a disk in this drive, so we'll take just a random disk, put this into the drive, and now we'll try and format that disk. So we're going to use the copy command. It's actually copy.com, it's a program rather than a built-in CPM command. We're going to format drive B. And as you can see, it's working. So I have actually now repaired this, and I thought what I would do in this video is go through what I found and the reasoning behind why I did what I did to try and fix this. But in terms of testing, no, I haven't just formatted one disk and assumed that it's now fixed. I've actually formatted all these, and I've done this after powering off, powering on, doing all sorts of other things in between, and it now works 100% reliably. So as I said, I thought I would go through in this video the thought process, so you won't see much repairing in this. I will tell you what I found. So if you're wanting to see more repairing or the fault finding process, then you might want to skip this particular video. But I started off this part of the repair when this fault popped up by saying it would be fairly interesting. And in fact, when I first saw this fault, I assumed it was a fault that had developed in drive B, which is the one I was trying to format the disk in. And it's also possible it was a problem with CPM. It's fairly unlikely. CPM's been around a long time, but the particular part of the system that was being used to format was the copy.com program, and that's on this particular Osborne boot disk. It's not an integral part or a common part of CPM itself, so it's possible there was a fault with that. So what I did before I touched anything was I contacted a couple of people that use CPM fairly extensively and asked if they'd ever seen a fault like this, and they hadn't. So I kind of assumed at that point, I know you shouldn't assume, but kind of came to an educated conclusion, let's say, that it's fairly unlikely that the problem was in CPM, otherwise other people would have seen something similar. It is possible, of course, and of course it can be a side effect in CPM. One of the problems on old machines like this is they do not have a lot of error checking, and I developed systems for a living, ran my own company, and especially once you really start doing it on a professional level, about 80% of the code you write for a particular project is actually in error handling and error recovery. But old machines like this do not have a great deal of that, so you'll find that a hardware fault can give you fairly subtle or fairly bizarre faults that are really unrelated to the particular part of the system that's causing the issue. So what I've been doing for the last 3 or 4 videos is kind of dropping hints. I figured out fairly quickly what the likely problem with this was, but because I wanted to get as much feedback and involvement as possible, I didn't attempt to fix this. I just wanted to go through what was really my thought process. Now that thought process was probably 15 or 20 minutes, but I can't really show you that, so I had to kind of stretch it out and show you what the thought process was by way of examples, such as looking at the source code and other various things. So we now have a fully functional machine as far as formatting is concerned. There are other faults I'm aware of with this. But there were 2 major faults that were causing this, one in particular that was causing this, and other faults as well. Now, most of the comments I received on this were kind of focusing on really the wrong part of the issue, and I was giving hints that the fault was not necessarily with the drives or the drive system itself. And so when we first started this, I showed the memory map for the Osborne, and it's a 3-bank memory maps. We've got a system on the main board that allows you to select one of these banks, and as with most CPM machines, the bottom 100 hex bytes are reserved for CPM. We then have the user program part, we then have BDOS CCP, the BIOS, and then a RAM area, and at the top in this particular machine we have the video display. There's an extra 4K of RAM in this machine, which are these 2 devices on the daughter board that are for video attributes. So it's a fairly easy system that's used in this to switch between the banks, but the important thing to bear in mind is that while the top part of the RAM system, at least the banks 1 and 2, are shadowed, so if you got bank 2 selected and you try and access this part, for example, you're actually accessing the RAM over here. This doesn't really exist as physical RAM. But the bottom 4K, it's not shadowed, it's completely separate. So if you're in this bank 2, and you access an area down here, you're accessing ROM, whereas if you're in bank 1, you'll access RAM. And that's an important thing to bear in mind. That's why I introduced that fairly early on. I also said there were other issues with keyboard reading and scanning. I had a question about whether it could be an interrupt system that was causing delays and hence preventing the disk access functions from working correctly. It's extremely unlikely with this particular machine because the interrupts are fairly minimal, and also the speed of operation of the disk read compared to the speed of operation of the CPU is extremely slow, although it seems to be going quite quickly compared to the CPU execution speed. It is running at a snail's pace, so you'd have to have a situation where the interrupt wasn't really returning for anything bad to happen. Now, it is of course possible that during the interrupt something's going wrong, but that's kind of covered off by the fact that we were doing other tests as well. I showed it probably wasn't the drives themselves by attaching a Gotek, and someone said that the firmware in the Gotek is very flaky, so that could be causing a problem. Yes, it could, but it's very unlikely you'd get an identical problem using a Gotek compared to the drives. And I also said that I tried 2 spare drives and they did exactly the same thing, so again, very unlikely that it was either of the drives. So possibly it was a RAM issue, and I reattached the Fluke 9010A, went through probably 4 or 5 times a long RAM test. That took about 10 hours to complete that testing, didn't get a single issue, so it was fairly unlikely it was a RAM fault. Now, it's still possible it was a RAM fault because I had to slow the board down to do the RAM testing. But once I'd completed that, I ran I put the normal crystal back in so it was running at the proper speed, ran the diagnostic program that runs the RAM test at full speed, and again that passed without any issues. So it's quite strange. Now, the other strange thing was that when I ran the disk diagnostic program from that same floppy disk, the drive and the drive system passed with flying colours. We weren't getting any issues whatsoever, so it was successfully reading and writing to the floppy disk. However, copy or format was failing. So when you start putting all these things together, you kind of form a mental picture of what might be going on. And so I then started looking back at the system itself. So if we look at a diagram, this is out of the Osborne 1 technical manual. If you look at the diagram of the system, there is a clue in here as to what might be going on. And as long as you can get away from the idea that it's necessarily a fault with the floppy drives, and that's an advantage that I had, that I kind of never assumed that just because, for example, a floppy drive is failing, that that's where the fault is. I've worked on so many of these systems that the fault, it can just be a side effect of something else, and someone said, well, it could be a buffer chip or something like that, which is probably the closest I had to the correct answer and the thing that I was thinking. So what I did then is I just walked away from the machine for a couple of days, and I just thought about it while I was working on other things, and came to a conclusion that I had a vague idea what it might be. Now, with most systems it would be very easy to test it, but I couldn't test it on this machine for reasons I'll come back to in a few minutes. So if we look at the diagram of the system, there's a good clue here as to what might be going on. So what we've got here is the CPU, we've got the ROM and the RAM, they're in separate banks of course, and then we have part of the RAM being used for video display, so there's a data path from RAM to the video, and then through the character generator, etc., to the display. We've then got a path onto the data bus, address bus for the ROM and for the RAM. But so we can read the RAM, there's also a buffer that allows us to get the data out of the RAM and to the CPU, which of course you need to do, otherwise you couldn't access data in the RAM. and of course there's a way to write data into the RAM as well. And also we've got the PIAs, UARTs, keyboards, etc. that are used to send data out of the system and to read data from the ancillaries. We've then got the disk control, so this is really the disk control chip, and then we've got the drives themselves. And this appears to be where the problem was, but as I said, I very quickly came to the conclusion that's not what the issue was. So we need to start looking at what links all these together, what's the common denominator in all these problems. And I was going through the source code, so I spent probably a couple of hours going through the source code, making notes as to how this was developing, and as I was going through this, when it was failing, I was getting failure at random points, and that's quite a big clue in itself. If it was a fault with a particular aspect of the system, then generally the fault would be fairly consistent. So even if it was something like a mouldy floppy disk, you would tend to get a failure in the same part of the code all the time. So the way this formats disk is it will write a block of code into RAM. It will then transfer that RAM into a buffer, and then it will try and write that out to the floppy disk through the disk control system, and it will then try and read that back, and it does that one track at a time. In fact, it does it one sector at a time. And if that fails, it will flag that up as a failed track format. And it will do something similar when you try and copy data. The important thing here is to remember that it moves the data around a block at a time. And that's kind of where the clue starts to come in, because we know that the disk test software works. It wasn't flagging up any faults with the disk, and it was definitely reading and writing from the disk and to the disk, because halfway through I turned the machine off, took the disk out, read it in the CryFlux system, and I could see the data was on the disk. So I knew it was actually capable of writing to the disk. It just wasn't doing that during a format. So when I got a failed format, there was no format data on the disk. It just wasn't writing data to the disk. And I'd already at that point eliminated the idea that it was a problem with the disk drive system itself. So I started looking into the code in more detail and wondering why it was working with the disk diagnostics but not with the format. And again, if you're familiar with this type of system, you'll know that quite often speed plays a big problem with some of these weird faults that you get. Now, I already knew there was a problem with the keyboard driver, because what it would do is, if we look at the keyboard drive electronics, it's got these row drivers, and if you press a key, it links one of the row drivers to one of the column lines, and then the system can figure out which key's pressed. But there is not a lot of error detection in the keyboard scan routine. But it is in some ways quite a clever routine, because it stores multiple key presses and then it processes them later on. The problem is, if it stores a weird combination of key presses, it can do odd things. And what's happening here is, because of the large capacitance between these adjacent lines, when we got a pulse on one of the rows, it was being transferred onto one of the other rows, and it was doing that fairly randomly. And the problem there is it thinks there are multiple keys pressed. I'm not saying multiple, I'm talking it might think there are 8 or 9 keys pressed all at the same time. And the system really does not handle that very well. It tends to do very strange things, and when it gets to the lookup part of the key scan code, it just does odd things, and that was interfering with the overall process. But I'd already eliminated this some time ago. I mentioned this quite a while back, and I dealt with this by putting some load resistors or pull-up resistors on the row lines. They're on the back of the main board. I'm probably going to move them to the actual keyboard and put them on this interface board, because it will work better and eliminate noise down the cable. So I knew it wasn't that anymore, and I did have a quick look using the logic analyzer, and I was getting nice, not clean signals, but nice consistent single key presses unless multiple keys were actually pressed. Now this manifested itself in some odd ways in that it looked like the keys on the numeric keypad on the keyboard weren't working, and yet I could see the signals on the interface electronics. So I knew it wasn't the keyboard, and the problem was it was just seeing them as multiple key presses. It thought the entire or all the keys on a given row were being pressed at once. In fact, it thought all the keys on a different row than the one it was energizing were being pressed, and so it was getting very confused. That fault went away, but I still had the format issue, and that's the one that I've been showing in the last few videos. So what I started looking at was what can link all the things together that I've shown in the previous few videos. And as I said, there is a very good clue in this diagram. And even more so, if we look at the code for reading and writing, if you're familiar with the Z80, it's got a very powerful instruction that's termed the LDIR instructions. So it's almost like a DMA system built into the CPU, and what it allows the system to do is move blocks of data using a single instruction. So what you do is you load the source address, destination address as pointers and a count of bytes to move, and then you just leave the CPU and it will do that almost like a DMA system. It doesn't really process it, and it's extremely fast. And when I was running the logic analyzer, I could see that that's the method it was using, because suddenly when it got to the point of moving the data around preparing for a read or write, I was seeing a sudden flurry of activity on the data bus and at the address of the buffer that had been set up for the disk drive system. So I knew that's what it was doing. And then when we trace through the code, we'd get to this block and we'd end up with this instruction here, and that's fairly autonomous, and another reason why I didn't think interrupts would be causing this problem, because that's done from within the CPU, so an interrupt isn't going to disrupt that, and in fact that process can be interrupted and it will then continue without any major issues. So that comes back to what was causing the problem. So the next thing I started considering was, well, it only does it when it's moving data around quickly, and then only between certain points. So when we go back and look at the layout of the memory system again, we have two issues. One is it was only causing problems when I was running code from RAM, and that's with the copy.com. So when we run the copy.com, CPM copies that into RAM at this location, assuming nothing else is loaded, and then it starts trying to execute that code from here. And again, we were seeing that on the logic analyzer. We were seeing the addresses when the copy.com code was accessed, and that's the point at which things started going wrong. And that's how the code in the diagnostics differs from the code we're running when we're formatting. So the other issue we had is that the data, when it was trying to move rapidly from one part of the RAM to another using the LDIR command, it wasn't successfully, or it appeared not to be successfully moving the data, and that's what I assumed was causing the failure on the format. It wasn't that it wasn't able to read or write the data, it just wasn't reading and writing the correct data, and that data includes the header data for the drive, and if that's not written properly, the drive will become, or the disk will become, unreadable. So I believe that's what was going on, because that is the only thing I could think of that would tie all the faults together that I was now seeing, and they're all the faults that I've kind of dropped hints at over the last sort of 3 or 4 videos. So what would prevent the CPU from being able to move data around? The Osborne's a very simple machine in terms of its RAM. In fact, the RAM control system is quite clever, and it's probably one of the few parts of the machine I quite like, because it's quite powerful. It does have some limitations, but it's quite powerful for use in a system like CPM. So I went back to the block diagram for the system, and the only thing really here that's common to all the issues we're having is not being able to get data in and out of RAM properly as far as the CPU is concerned. And the only thing that's common there is this. And if we look at the schematic, that is actually provided, that functionality is provided by this bidirectional buffer. So the most likely issue that we have, as far as I can see, is that this buffer was misbehaving. And again, going back to previous experience repairing this type of machine, these are fairly notorious for causing issues. This is a 74LS244, and I do replace quite a lot of these each year. So the reason I couldn't easily test this, I mentioned earlier the normal step would be to throw a logic analyzer or logic comparator or a scope on this just to test the signals coming in and out. That's not that easy because it's underneath the daughter board. Now I could of course flip the boards down, start trying to test it that way, but it's not really a very good way of trying to test this machine. So I decided just to assume I was correct. Again, you shouldn't really assume things, so I took the thing apart, replaced this device, which is this one, put it back together, and now it works perfectly. So just by thinking through the problem and thinking what the common denominator is, then it enabled me to take a very good guess as to what was causing this very weird problem that didn't seem to be directly related to any one thing within the system. And sure enough, it's just because it wasn't able to access the data that was in the RAM reliably when running at speed. And I think the reason that the system would slowly recover if I just kept doing this is the device was probably warming up, or the power supply was warming up and things were changing slightly, and that enabled the chip to start working. But it just seems that it wasn't able to move the data around from buffer to buffer fast enough, and it was corrupting it. And during that process, that's only used when it's reading and writing the floppy disk, and it doesn't do that when it's running the diagnostic program, which is why the diagnostics works and yet the format and the copy don't. So that was my thinking behind this. Hopefully you found the fault finding process of some help or interesting, but it was just going through, seeing exactly what the machine was doing, looking at the firmware, seeing what the firmware was doing, seeing where it was failing, and then putting all this together in such a way that I could kind of make sense of what the system may be doing and what could be causing the fault. So this is a final step in this video. We'll put the device into the tester and we'll see if it actually shows us faulty. And sure enough, it's showing as faulty. I did try this in another tester as well and it shows as working, so it's not completely failed. It's kind of one of these devices that's it's not fully meeting the spec, and while it was testing, what you can do with these testers, by the way, is put a scope on during a test and you'll see how well the device is working and see how well the outputs are responding. And if you do that, I find that this device has got on two of the outputs extremely low outputs that are quite slow to respond. So I think it's just a couple of the bits weren't really giving the outputs that was required to reliably switch what they were trying to drive, and that's where the fault was. So having replaced that, we've now got a system that can successfully write to and format floppy disks. As I said, I've formatted probably 35 or 40 now, all different types, put some in that I know won't format to try and provoke it into misbehaving, and then putting in a good disk or a known correct type disk, trying to format again, and it's worked first time every time. And that includes disks that have I got some disks that I know are damaged, and I keep those for this type of testing because I want to see what happens when a format fails. So this is now working correctly. As I say, I hope you found that interesting. Just don't assume that just because something is wrong with a particular part of the system that that's the only place you should look. That in an old machine like this, the fault can be anywhere, and the best thing to do then is don't start tearing it apart. Start investigating it, think through the problem, see what is common in terms of what parts of the machine are involved, and then hopefully that will allow you to zone in on a particular device or part of the system that you can then investigate further. So in the next video in this series, we'll start looking at the case. It needs a lot of work, it's very badly yellowed, bit of damage, and we can then start reassembling this and working our way through any remaining faults.